Hello people, welcome back, and today we're going to be looking at the AQA specification 4.5, which talks about energy changes, and in the Carbureau book is chapter 7. So let's jump into it.
It was a nightmare.
Activate.
Okay, so here we have it, guys. This is the last bit for your paper 1 chemistry exam. What you got here is energy changes. Okay, now we're going to be looking at exothermic and endothermic reactions, energy transfer during exothermic and endothermic reactions. Okay, now the first thing you want to understand here is that the conservation of energy, that energy cannot be created or destroyed, it just changes form. Okay, now you have two types of chemical reaction. You have an exothermic reaction, which releases more energy than it takes in, and then you also have an endothermic reaction, which takes in more heat, the more energy than it gives out. Okay, the exothermic reaction gives out more energy than it takes in, but the energy is given out in the shape of heat, and the endothermic reaction takes in more energy than it gives out, so the reaction actually goes down in temperature and it gets cold. Okay, some examples of exothermic reactions: you're looking at any burning, any combustion, any neutralization reactions, oxidation reactions as well. Those will all be exothermic reactions. Okay, and we also have endothermic reactions, which we're looking at something like what's it called, thermal decompositions. We have photosynthesis, for instance. They take in a lot of energy from the sun in order for the chemical reaction to happen, and that energy from the sun is stored in the sugar. And some of those normal usages that you have for endothermic reactions, you'll be looking at ice packs. When you have to break them, you get the chemicals mixing each other and they produce the chemical reaction, which absorbs the energy, making the pack feel cold. And in exothermic reactions, you will have normally the self-heating cans as an example, or the hand warmers. Okay, now the self-heating cans will be a question. They might ask you a question to evaluate self-heating cans and hand warmers. Okay, or two types of hand warmers, for instance. Okay, because there are some hand warmers where you can use them once, okay, and they give you a lot of energy, but it doesn't last for too long. Okay, it gives you loads of energy, very nice and warm for a couple minutes, maybe hours. And then you also have the reusable ones, where the amount of energy given out is not as much as the one use hand warmers, but the advantage of this one is that you can keep on using them over and over again. Okay, so they might ask you to try and describe the differences between those and which one is more I don't know, more cost effective or something like that. Okay, by this, in essence, they will ask you to compare those two. Okay, distinguish between an exothermic reaction on the basis of temperature change in the surroundings. Evaluate the uses of applications of exothermic reactions when given appropriate information. Okay, this here, what they might do is give you a table of results from an experiment that somebody has done, and in the table of results you have all the temperature changes all the time. They might ask you to plot a graph. All right, and that's a whole nother story, because a lot of people have a lot of difficulty in graphs. Because it's required practical, it's very likely that you will get a 6-mark question on this. Okay, so you will have to look at the information, extract that information. You might have to draw a table of results from the graph, or make a graph from the table of results, whichever way it is. Okay, limit to the measurement of temperature change calculations, and the energy changes is not required. Okay, at this point you won't require to get this done. Practical, investigate the variables affecting temperature changes in reactant solutions, such as acid plus metals, acid plus carbon, and neutralization, displacement reactions of metals. Okay, so again, if you require practical, your question might be about any of these law. Yeah, but essentially it is just the same thing in principle. You want to identify whether the reaction is endothermic or exothermic, and then you have to explain your reasoning. Okay, if you already do that, if they do that and they tell you what it is, and they ask you to make a practical report, you have to write down the steps. They might ask you to do some safety measurements, safety precautions, like wearing goggles, hair tied up and stuff like that. Very easy thing. Okay, it's a bit lengthy, but it is worth tackling these 6-mark questions. Okay, reaction profiles, and this is where you got those profiles that look like a little hill, and then they go down, right? So that basically what you need to remember is that for an endothermic reaction, the reactants are going to be lower than the products. Okay, so you have the reactants at the bottom, you're gonna go up the hill, and that hill is the activation energy, and then down the hill, and then that will be your products. But down the hill is gonna be a lot smaller than up the hill, which means that as you go up the hill, you add in a lot more energy into that endothermic reaction, and when you go downhill, that's the amount of energy that gets released. Okay, so that means that the reactants have a low amount of energy, and the products have a high amount of energy when it comes to endothermic reactions. Okay, some examples of that would be, like I said before, it would be the photosynthesis, that the reactants don't have a lot of energy, the oxygen and the water don't have a lot of energy, they're taking all the energy from the sun, and when the reaction is completed, you end up with glucose and oxygen, and a lot of that energy is in glucose, and that's why the energy levels of the products remain really high. Now when it comes to the exothermic reaction, it's going to be the opposite. You will have the reactant somewhere maybe along the middle of the diagram. Then you go up the hill, which is the activation energy, and then you go down the hill, which is the energy being released once the products are formed. Okay, so always, because a lot of more energy was given out, that's like going down the hill. A lot of the down the hill is bigger than up the hill. That means that a lot of energy was given out. Normally the products are gonna be lower than the reactants, because the products gave away all that energy, so the energy levels are low. All right, and that's one thing you're gonna remember. You can't get those confused. A lot of the time it's gonna be 2 to 3 marks. They might be asking you to label it. So up the hill, from the line that says product, up the hill, that will be your activation energy. From the top of the hill all the way to the bottom, that's your energy release. And the difference between those two, that's gonna be your delta H. That will be your change in energy. All right, it's gonna be talked to as the change in energy, and that will give you your nice 2 to 3 marks. Okay, for something as easy as labeling a diagram. Okay, it says draw a simple reaction profile, so they might even ask you to draw it yourself. Okay, and this is why that if you get stuck in a question, you want to move on to the rest of the test, and then as you go through the rest of the test, it might jog your memory. There's been cases where the students have been asked to draw the reaction profile, they leave it empty, and when they go to 1 or 2 questions down the line, they are given a reaction profile to try to explain, or on a multiple choice question, and there you have it. That is your answer right there. A lot of the time the answer for the questions is in the question itself. You just need to know how to read them, and you need to know how to pay attention to them. Okay, using the reaction profiles to identify reaction as endothermic or exothermic. So they might give you a reaction profile where the products are below and the reactants are lower than the products. That means that it will be an endothermic reaction, and if the products are lower than the reactant, then that will be an exothermic reaction. Okay, energy changes in terms of electrons. Well, in here you might be asked to look at the energy changes, and this is when we're talking about bond making and bond breaking. Okay, so when you are in the reactants, right, the bonds between those atoms that form the reactants, the chemicals that are reacting, you have to break those bonds. Okay, those bonds need to be broken so that they can be reshuffled and turn into something different when it comes to the products. Okay, and this is only for higher. Okay, this is only for higher tier, right? So what would happen there is that you need energy to break the bonds in the reactants. That's what your activation energy is for. And when the new bonds are created, energy is released. All right, and that will mean that breaking bonds needs energy, making bonds releases the energy. Okay, that's the main idea that you want to have in there. Okay, you're gonna have to look at the bonds. They will give you a table with the amount of energy for each bond it is gonna have, and then you need to just find out how many bonds you have, add them all together. That's your energy in. Find out all the bonds that you have in a product, add them all together, add all the energies together, and you have 2 sets of energies. You gotta have to take away one from the other, and that's it. It will tell you whether the reaction is endothermic or exothermic. Very, very, very easy. Okay, you might be looking into chemical cells if you're doing the triple science. So when it says here chemistry only, that will be triple science. When you look at here that says higher tier only, that's for higher say combine higher, because you can do combine, higher, and foundation, and you can do triple, higher, and foundation as well. Okay, something like that. So yeah, so this will only be if you are in doing triple science. Okay, talking about cell batteries, it will talk to you also about rechargeable and non-rechargeable batteries. It's gonna talk to you about hydrogen fuel cells as well. How does it work? What are the things that are given out? So this is cells and batteries, and then you got fuel cells over here, and this is when we're talking about the hydrogen fuel cells. So you might want to watch a couple videos and get yourself a diagram and label it, that will help you understand how these work. Okay, the batteries, as they become oxidized, they need to be recharged, so the movement of the particles will, from one place of the battery to the other and whatnot, that will be in rechargeable batteries and so on. But like I said, this is very easy. You watch a couple videos, you make a couple notes, you draw a diagram, and you label it. It's important that you label it, because it's gonna help you understand it very, very, very good. Okay, and that's that for you. Okay, after that we got rates and extended of chemical reaction, but that's gonna be for your paper 2. Okay, so you don't worry about that anymore. This is the last things that you will get in your paper 1. Well, there you have it, guys. That is the last topic for your paper 1 chemistry. I hope you find that helpful, and if you do like it, share and subscribe, like the video as well, and if you do have any questions, leave them in the comments and I'll try to get back to you as soon as possible. Remember, knowledge is power. See you next time.